Hi, I'm coming in for a second. So today's lab, we're going to look at equilibrium conditions and torque on in this case, hanging meter stick. We're going to apply various forces to this meter stick and use equilibrium conditions to solve for various things. I'm actually going to walk through the entire lab today. It's a kind of quick one. Collecting the data as we go. There is a few steps I need to know. First is I need to know how much the weight of the meter stick or the mass of the meter stick. I have already measured that. I also will need, and I can bring this in, to figure out where the center of mass is. aka if I hang it, where does it hang to balance flat? And as you can see, this is 52 centimeters or 0.52 meters. Sorry, just re-straightening. I also am going to hang everything by these clamps. I need to know on average how much they weigh, because the mass that I'm going to hang at each spot will be the mass I hang plus the mass of the clamp. I found these clamps weigh on average 21 grams or 0.021 kilograms. So for the first bit, I'm going to hang 100 grams or 0.1 kilograms at the 15 centimeter mark on the meter stick. The 15 centimeter mark is what I'm going to use. When I say place on the meter stick, that's my X values in this lab. So I'm saying X is 15. So I will hang this right at 15. And then it tells me to hang a second mass weighing 0.2 kilograms. Keep in mind it's not actually going to be 0.2, but it's going to be 0.2 plus the mass of the clamp, which I already put in for you, wherever I need to balance this flat. And so I'm going to put the second one on and just figure out where it balances. Close. That spot where it balances, which, pretty close to flat, that's our equilibrium condition. Now, probably too far away to see, but I'll read it for you. That is at 0.65 centimeters for the value of X. So I can use that, or 0.65 meters, sorry, 65 centimeters. I can use that to find O. O will be the distance from there to there. It will be this 0.65 minus this 0.53. What I'm going to do is use that my experimental value of 0.65 would just be from doing that subtraction. For theoretical value, what I'm going to say is I know this distance O, I know this mass, I know that mass. We're going to use the sum of torques equals 0 to solve for O. Saying torque 1 plus torque 2 equals 0. Don't forget to keep track of if it's a clockwise or counterclockwise, or if it's a positive or negative torque. The second bit, I'm going to keep 0.1 kilograms, except now I'm going to put it at the 30 centimeter mark. I'm going to hang 0.2 kilograms plus the clamp again at the 70 centimeter mark. And I'm going to hang just 50 grams, aka just the mass I want plus the clamp, wherever I need to balance. My goal is to figure out the value of O. This is from here to the pivot point for this situation. My experimental value will be whatever this reads when it balances, which is right there, which is 23. Sorry, I just realized I read the number wrong before. 23.3 centimeters, or 0.233 meters. And so the experimental value would just be from there to there, subtracting the two values. And for theoretical, once again, we'll say the sum of torques equals 0. This torque plus that torque equals 0. Rearrange, solve for all three. Realize the first one I said was 0.65, it was actually 0.695. That was my bad, I misread it, but I have fixed it. In case 3, we're going to leave our 0.1 kilograms at the 30 centimeter mark, and we're going to find out how much this unknown piece of metal weighs. How we're going to do that is for a theoretical value, I will go put it on the scale. I'll do that for you. It is 70 grams. And then I'm going to hang it and figure out where when it hangs do I balance flat. Very interesting video, I know. It's a lot more fun when you're doing it, not just watching a video of it. I hate everything about doing this online. Okay, so there we go. That's at balanced flat. That's going to be at 77.3 meters. That's the value of x. So we can solve 0.737 meters. Sorry, 773. I misread. So we can solve for all unknown by subtracting again. Now, this one we're going to actually be solving for the mass. So what you're going to do is this, you're not going to solve for that distance. That distance is what we can give by subtracting. But you're going to solve for the mass by saying this torque plus that torque equals 0, rearranging, solving for m. Keep in mind when you solve for m, that clamp will be included. So once you're done, subtract out the mass of the clamp. And for the last one, I'm going to take this off, and I'm going to hang 0.1 kilograms at the 10 centimeter mark. I'm then going to move this and figure out where I have to be to balance with nothing else. Oh, nope. You know you miss doing this on that. Ah. There we go. Okay, so what I can see is to hang this like that, I need to have it centered at 20.67 centimeters or 0.267 meters. That allows for an equilibrium condition. I want you to solve for the mass of the meter stick. What we're going to do is we're going to say we have two torques, this guy, and one from the center of mass of the meter stick going down. And we'll use sum of torques equals 0 to solve for m stick. So that's going to be 4 different things you're solving for. For each of these 4, I also asked you to find percent error, comparing your theoretical and experimental. I also asked for a free body diagram. You're going to make sure you draw a free body diagram, and that will need to be uploaded with the lab. That should be it. Thank you.